Okay, we're going to get into 6.4 vectors and dot products. You're going to be able to find the dot product of two vectors, find angles between the two vectors, write vectors as a sum of two vector components, and also use vectors to determine work done by a force. So these are the basic properties of a vector. So something I want you to take a look at or pay attention to is the dot product here. And notice what you're doing. You're just adding together. You're multiplying and adding together. Now these are the basic properties of them after you've done the dot product. And so this is just your magnitude. Okay, let's move on. So first we're going to find the dot product of this first one. And so if we take a look here, all we're going to do is we are going to go 4 times 2 plus 5 times 3. Which is going to give us 8 plus 15, which is 23. So when you do the dot product, you should see that you get a number. All right, let's move on to the next one. So we're going to go 2 times 1 plus negative 1 times 2. So we've got 2 minus 2, which equals 0. All right, next one. 0 times 4 plus 3 times negative 2. So we get 0 minus 6, which equals negative 6. All right, go ahead and pause and give the other two a go. And as soon as you're ready, just go ahead and jump back on and I'll give you the answers. I hope you got it right. Okay, let's move on to these next ones. So now we're going to do A. So the first thing we're going to do is we're going to do the dot product. And then once we get done with the dot product, we're going to actually multiply by W. So remember, the dot product gives you a number. So for the dot product, we're going to go U times V. So negative 1 times 2, or U dot V, I should say, plus 3 times negative 4. So we end up with negative 2 plus negative 12, which is going to give us negative 14. So that's this part. So we've got negative 14 times W, and W is this, so therefore our answer should be negative 14, 28. Okay, let's go on and do the next one. We'll do it in green. So this time we're going to go U dot 2V. So the first thing, so what I'm going to do is I'm just going to pull that 2 out, and I'm going to go ahead and do U dot V. So 2 times, and then U dot V is negative 1 times 2 plus 3 times negative 4. So now we've got 2 times negative 2 minus 12. So 2 times negative 14, which is going to give us negative 28. Okay, let's go on and do the next one, and we'll do that one in red. So now what we're doing is we're finding the magnitude of U. So remember, with the magnitude, it's just doing like the Pythagorean theorem. So with U, we want to do the square root of, and then U, so we're going to go negative 1 squared plus 3 squared. We end up with the square root of 1 plus 9. So the answer is the square root of 10. Okay, go ahead and do yours. So go ahead and pause this video, give it a go, and then come back in when you're ready for the answers. And here's the answers. Okay, now we're looking at angles between two vectors. And so what you want to see here is the cosine of theta is going to be equal to your dot product of U times V, and then the magnitude of U times the magnitude of V. Or if you solve this and you want to do it, here's another alternate form, but that's going to give you the angle between two vectors. Okay, so we want to find the angle between these two vectors, so we're going to use cosine theta is equal to our dot product over the magnitude of U times the magnitude of V. So let's go ahead and do our dot product. So U times V means 4 times 3 plus 3 times 5 all over, and then you're doing the Pythagorean theorem, so 4 squared plus 3 squared times 3 squared plus 5 squared. So we get 12 plus 15 over the square root of 25 times the square root of 34, which is going to give you 27 over, and then when you reduce that down, square root of 25 is 5, so 5 times the square root of 34. So now what we want to do is we're trying to find theta. So what we want to do is we want to do the cosine inverse of 27 over 5 square root of 34. When you plug that in, you should get approximately 22.17 degrees. Okay, go ahead and pause, give it a go on this next one, come back on when you're ready to find out the answer. And the answer is 45 degrees. Okay, next thing we want to look at, we're looking at these angles here. It just kind of gives you an overview. And then we're looking at what an orthogonal vector is. And an orthogonal vector is just that vector that when you do the dot product, you end up with 0. And if they are orthogonal, that means that they form a 90-degree angle. Okay, so let's see if these are orthogonal. So we're going to go ahead and do our dot product. So we're going to say 2 times 6 plus negative 3 times 4. And you get 12 plus negative 12. Therefore, they equal 0, which means this is 90 degrees. So go ahead and try the checkpoint. Go ahead and pause. Come back when you're ready. And obviously, these ones were orthogonal as well. Okay, so now we're getting into some ways to apply this, and this is a lot of physics here, that you'll be using this in physics a lot, but it's just kind of explaining how. So if you take a look here, like the vector components of u, and so it says that the vector w base 1 is the projection of u onto v, and it's denoted by here. So, and then here, down here, is the equation to find that projection of v onto u, and we're going to use that equation. Okay, so here it says find the projection of u onto v, then write u as the sum of two orthogonal vectors, one of which the projection of u onto v. So let's do the projection first. So the projection of u onto v would be u dot product over the magnitude squared times your vector v. So if we want to do the dot product, we're going to go 3 times 6 plus negative 5 times 2 all over, and if we do the magnitude of v, so that means we're going to do like the Pythagorean theorem, so 6 squared plus 2 squared, but remember this whole thing is squared, and then we're going to multiply that whole thing times the vector, the vector b. It's just a lot of math here. So we've got 18 minus 10 all over 40 times my vector 6, 2. So we end up with 1/5 times 6, 2. So my answer would be 6/5 and 2/5. Okay, one thing I should have told you is this one here is your w base 1 vector. So what we need now is we need our w base 2 vector. So if you remember, our formula was u equals w base 1 plus w base 2. We have u, but we need to find w base 2. So for our second vector, we're going to go u minus w base 1. Okay, so our u is 3, is going to be 3, negative 5, minus, and the vector that we just found, which is our w base 1. So what we've got for our w base 2 is going to be 3 minus 6/5, and then we've got negative 5 minus 2/5. Remember, we're looking for a vector. And so when you go ahead and do that, you end up with 9/5 and negative 27/5. fifths. So that's our W2 vector. So U is equal to W1 plus W2. We are using write U as a sum of two orthogonal vectors. So our W1 is 6/5 and 2/5 plus 9/5 and negative 27/5. So when you add those together, you end up with 3, -5. That's your vector. All right, go ahead and give that a go. So go ahead and pause and see if you can figure out the checkpoint. Come back on when you're ready. Okay, here's the answer. So here's your first one, your projection one, and then your U. Okay, so hang in here with me on this one because this is going to take just a little bit of time, but we're going to be finding the force. So you have a 200-pound cart. So when you think of force, I want you to think about it's -200. That is your force down, and then your vector is J. So you're doing 200-pound cart, and that's like doing force according to gravity. Okay, and that's what the J is it's kind of like your gravity thing. Okay, so then if we think about this, the other thing it gives us is 30 degrees. So our V is going to be the cosine of 30 I plus the cosine of 30 J. So that means V is equal to the square root of 3 over 2 I plus 1/2 J. So if we want to put this in vector form, the square root of 3 over 2 and 1/2. Okay, so now what we're going to do is we're going to do the projection of this because we want to find, let me get this. This is what we're looking for, the projection of the force onto V, which gives us F dot product V over the magnitude squared of V times the vector V. So the first thing we need to figure out is we need to figure out what is the magnitude, this part here. So if you think about that, here is our V, so we're going to do the Pythagorean theorem. So the square root of 3 over 2 squared plus 1/2 squared, and then this whole thing squared. And what you end up with is 3 over 4 plus 1/4, which is going to give you 1. So that kind of makes things easy. So when we go back over here, we've got F times our V over 1 times V. Okay, so what I want you to remember is when we did our force, this is what we were talking about. So actually, we've got -200, and then remember it says with the J. Well, here's the J times 1/2. Okay, and then we'll multiply that times V. So we've got -100 times our V, which is the square root of 3 over 2I plus 1/2 J. So if you think about it, that means that our force on our, what our force is going to be is it's going to be -100, but you really can't have a negative force. So your force is actually 100, which is what we got from that. The force times our vector. Okay, go ahead and stop this and give yours a go and see if you can figure out the checkpoint and come back when you're ready. So your approximation should be about 38.8. When I did it, I was a little bit off of that, but I think it's only because of rounding errors, because you have cosine of 15, so you don't really have like those perfect little numbers like we had before with the square root of 3 over 2 and 1/2. So it should be around there. Okay, so now we're going to start talking about work. And work W done by a constant force acting along the line of motion of an object is given by, and what you do is you do the magnitude of the force times the distance. That's what work is. So, and then it says, as shown in figure 6.31, when the constant force F is not directed along the line of motion, as shown in, so this one goes with this one, but when you have an angle, now you have to come up with something else. And that's where we come up with this situation. So here are our two situations. Let's go ahead and give them a go. Okay, so here we want to close a sliding barn door, very fitting. As you know, I'm a barn kind of person. So a person pulls on a rope with a constant force of 50 pounds. So we know that our force is 50 pounds at a constant angle. And so now you know that you've got an angle. So we're not talking about that first situation. We're talking about the second one where we have an angle of 60 degrees and it's shown here. Determine the work done in moving the barn door. You want to move it 12 feet. So what we're looking at is that second one where the formula that we use is the cosine of theta times your magnitude of your force and then the magnitude of your vector. So we're going to do the cosine of 60, and what's really cool here is they went ahead and did the magnitude for us, so times 50 times 12. So once you put that all together, you end up with 300 feet pounds. Okay, go ahead and pause, give this next one a go, and see if you come up with the right answer. Pop on when you're ready to check your answer. And here's the answer for you. All right, we're on our last thing, vocabulary. So the vocabulary, the dot product of two vectors yields a scalar rather than a vector. And then the next thing, when you do a dot product, you go u1v1 plus u2v2. And then the formula, if theta is the angle between them, you got cosine theta, and that's where we just kind of solved our formula to get the magnitude of u over the magnitude of v. Number 4 is just your orthogonal, which means that the two angles form a 90-degree angle. And the projection of u onto v, we're going to go u dot v over your magnitude of v squared times your vector v. And then finally, we've got our two equations here for work. So we have the one where we are using the projection according to PQ of F times the magnitude of PQ. That's our first one. And then the second one is the easy one, FPQ. All right, guys, you're done.